Good afternoon, class. This is your professor, Mr. Rogers again. I apologize for not posting a video sooner this week. You all keep our island in prayer. We now have 3 cases of the coronavirus out here in the islands, and it's put a strain on trying to get things done in a timely manner. For this video, I want to basically go over some of the concepts we're seeing in Chapter 2 and Chapter 3. And so if you will, go ahead and open up IntelliJ, and we will create a new project. And once your project is open, just select Java, click Next. And we are not going to check that box, we're just going to say Next. And we'll call this variables and branching project. Click Finish, and it keeps bringing my window to the other screen, so let me expand this up a little bit. Okay, so your IntelliJ should be, IDE should be open. Click on the project window here to expand it, and you're going to drill down into this little window, this tree. Oops. Click on Source. You want to right click and go to New Java Class, and we'll just call this class variable demo, because we're going to walk through a number of different use cases for variables. Okay, so for our class in IntelliJ, one of the nice features of this is it will automatically generate the public static void main method for you. So if you'll type PSVM and tab, it will go ahead and create that. And it's just a little trick that will make your life a little bit easier. All right, so let's talk about variable declaration for a moment. A variable in Java, it's actually specifying an exact memory location for your computer. So if you think about the RAM that's installed on your computer, when you create a variable, it's actually taking up a specified location in memory. Java is doing that for you. So in this demo, I'm just going to create a simple variable. I'm going to call it int, let's say int my age equals 46, and let's see, I want to say int my child's age is 16. Okay, so now I've created 2 variables. One is my age, 46, and my child's age, 16. So both of these variables actually take up a memory location in Java, and we can see those variables. Again, this is another, what I'm typing here, the SOUT. This is a shortcut phrase. If you hit type in SOUT and then tab, it will spit out the system out print line. All right, so with that done, I'm going to type in a string literal and say my age is, and we're going to concatenate the string literal to my age and say my age. Now, using this statement, what we've done is we've used the system out println statement to output the content of the variable my age. And we can run that by clicking on the green triangle here that's aligned at line 2 for the public static void main method. And we'll run that, and it will show, very simply, the age. It'll show a string with my age. And you can see it outputs it here. My age is 46. Okay, so I'm going to create another string literal. System out println. My child's age is, and I'm going to do another concatenation. Now the string excuse me, the string literal here is in quotes, and I'm appending it, concatenating it to the variable my age. Now if I run this again, it should output both of those. And there we have it, my age and my child's age. All right, so this is very basic variable assignment. With variables, you always use left assignment, meaning that the value is on the right and you assign to the left. Okay, so variable is on the value is on the right and the variable name is on the left. When you create a variable, you're going to create it by first specifying the type. So in this instance, the type here is a primitive of type int. Then I'm specifying a variable name, and I'm using what's called camel case. I'm making the second word in my age capitalized, second letter, and I'm saying it equals 46. Your variable names, they can be any valid character that cannot begin with a number. So for example, if I try to say int 5 age equals 5, it's going to complain. And IntelliJ will go ahead and let you know this up front because it's evaluating the content as you type it. But to demonstrate, if I try to compile this and run it, the compiler is going to throw an error, and it's going to tell me that this is not a valid statement. And then it's expecting something right here. So your variables, when you assign a variable name, it cannot begin with a number. You can make it a textual number like this, 5 underscore age, but it cannot be an actual number like that. So variable names can't begin with a number. They can be text. Variable names can include, let's see here, 5. As you can see, you can include special characters in this. And if you, again, you try to run this, the compiler is going to complain. It's going to tell you that, hey, we don't know what that is. And it's basically saying it's expecting a semicolon at line 14, which is about right here. And you can see as I move the cursor around down below, it says line 8 at character 11. So if I move it to 14, there's 14, and it's saying it's expecting this. Well, yeah, because the next character doesn't make sense. So you can't include special characters in your variables either. Your variable names could be in this format, 5 number equals 5. They cannot be like this. They cannot include spaces. This is invalid. It's when you put a space, it's expecting something else to be here. Okay, it's expecting a equals, a plus. It's expecting something. You can't do that. So you can't have spaces in your variable names either. Let's take another look at this and do some other operations with variables. So for example, we can do some adding and subtracting. So I'm going to take out these variables here and I'm going to create a new one, and I'm going to say int age diff equals, and now I'm going to do the difference in age. So I'm going to say my age minus my child's age, and I'm left assigning it to the variable. Now when I output this, we can say system out println again. The difference in our age is plus age diff. And if I run this, we can see what the difference in age is. And it says the difference in age is 30. So I am 30 years older than my oldest child. Wow, that's crazy. Anyways, all right, so that's one operation you can do. Now, standard operations with variables, you can do things like parentheses. If you have a parenthesis, you must have an open and close. These are standard mathematical principles for your for using variables and calculations. So you can create all types of mathematical operations here. You could say int age multiplied, and I'm just wrapping this for purposes of reading it. My child's age. Oh, forgot the equal sign. And so we can system out print line the age multiplied. And here we're doing the calculation and we're assigning it. And then of course if we run it, it will output that multiplication that took place, 690. There's a whole standard set of type of calculations you can do with variables. You can do some things which are called left assign, let's say incrementers. So for example, if I say int I equals 0, and then down here if I say I plus plus, in that statement I am incrementing I by 1 and assigning it to itself. This is the same as saying I equals I plus 1. You can also do things like I plus, let's say plus equals 1. And this is also the same as saying I equals I plus 1. You could say I plus equals 2. And this would be the same as saying I equals I plus 2. So these are different type of incrementing facilities that you can do. Similarly, you can take I and you can decrement. And this literally means I equals I minus 1. And similarly, you can say I minus equal 1. And this will output I equals I minus 1. And on, just like we did with the incrementers. There's other operations you can do with variables. Some of these are obviously your plus, your minus, your multiplication, your division, but we also have what's called a modulus. All right, so your modulus is the remainder. So say I have a number like 51. So I'm going to create a number here, and I'm going to say my num is 51. It's a crazy variable name. Notice that this one here has the number in it, but it's at the end. This is a valid way for doing it. Okay, so we got 51, and now I'm going to say I'm going to take out just that mess because that doesn't make, it's not readable. My num. So we got my num is, and I'm going to say my num divisor by, and let's think about that real quick. Say 51. Let's say divisor or modulus of 6. Okay, so what this is going to give me is it's going to do the calculation of my num divided by 6, and instead of giving me what the division is, it's going to give me what the remainder is. Okay, so if we output this, we'll just say my num, and we run this again. We can see that the remainder is 6. So if you do this with things that are equal numbers, and sometimes this is a good test to see if the number is divisible by 2. This here will return 0 because the remainder of my num divided by 2, there is no remainder, so it will be 0. And we can demonstrate that as well. Okay, and there you can see there's the 0. Let's think about some other variable assignments here. Let's switch this up. I'm going to take out all of this input and this input, and I'm going to use the scanner class. In IntelliJ, you have to do an import. So at this point, when I start typing scanner, IntelliJ is going to prompt you to import the scanner. So just hit enter, and it will put up here import java.util scanner semicolon. And if you ever get confused of how to import a class, you have to import it through this manner. Okay, it could be other packages or whatnot, but just make sure you have the import at the top. I'm going to name my variable scanner. So here I've got a class, an object called scanner. I'm calling it lowercase scanner, and I'm saying equals new scanner. And the constructor for the scanner class requires a parameter, requires a system.in, as opposed to the system.out that we have been using. Okay, so with the scanner class, there's a couple of catches here. Your textbook doesn't really talk about it yet, but there is an issue that many of you are going to run into, and I recommend using the delimiter. So the way scanner works is it reads by spaces, and that's the default pattern that the scanner uses. So you can set the delimiter, and so in this example, I'm going to set the delimiter to be a new line character. Because typically when a user is entering something with the scanner, they'll hit enter, which is a new line, and anyways, it'll create problems. If you want to test this without using a use delimiter, you can do that, and you can see that it just jumps right over your code. So you want to use this use delimiter. Okay, so we're going to say scanner, next int, and if I do this without putting a some type of a message, it won't make much sense. Let me demonstrate. So I run the program. The program now is going to be listening for input, and you don't see anything because it's listening for input. So I have to input something. So I'm going to input a 9, hit enter, and it exits. So to make your program more robust and more understandable, put a print line statement. I'm going to take out the line and just use print, and I'm going to say, please enter a number, use some carets and a space, and then we have the value that's entered. Now, what this scanner does is it's taking the value entered and it's expecting a number. And so if you input something that's not a number, it's going to throw an error. So we want to assign this value and say int num, and then we want to output it. So we use system out print line. You entered num. All right, so let's test our process here. Code's going to run. Please enter a number. I'm going to enter a 9. You entered a 9, and it exits. Now, you notice here, process finished with exit code 0. I don't know if I've just mentioned this previously. The JVM, when it exits a program, there are process exit codes that are dependent upon the operating system. And so I'm using a Mac, and I think a Mac and Linux, they both have an exit code of 0. Windows, I believe, is an exit code of 1. So it may be different on your box when it says exit code. All right, so we have the number. So now I'm going to say, ask for another input. So let's see. You've entered that number. System out. Whoops. System out. System out print. I'm not going to do the print line because I want them to enter the number on the same line for me. Please enter your desired wage. Okay. Use the caret symbols because it's a nice way to let someone know that they need to enter something, and then I'm going to say scanner next int wage system out print line. You entered wage. Whoops. I'm going to do another system out print line, and here I'm going to do the calculation of the two numbers inside. So I'm going to say your salary based on num and wage is, now here's the catchy part. If I don't wrap this extra calculation in parentheses, it's going to try to do some strange things. So let's just wrap that in a parenthesis. So we're telling it to calculate this number and then append it to the rest. So we're going to say num times wage. And we'll run this. Very basic program. Please enter a number. I'm going to say I'm a hard worker. I'm 50 hours a week working. And please enter your desired wage. I want to make a good salary, so I'm going to say 85. And there it is, 4,250. All right, so we've demonstrated some basic things with variables and calculations, and even using the scanner class. If we run this program again and we don't input correct values, for example, if we don't input a 9, say we input an I, we're going to get an error. And the Java runtime will tell you straight up, the problem is it's an input mismatch. Now internally, what's happening is it calls the next command, and next grabs a string value, and then it tries to convert it using next int. Excuse me, it uses next int, which calls the next, and next is trying to convert that value from a string into a number. Now, to give you an example, if we actually drilled into this code, and you can do that by clicking on it. Next, here is next int. It's taking in what it thinks to be a number. It's going to parse it into a number and return it. Otherwise, it's going to throw a number format exception. So behind the scenes, the value coming in, when you type this in, it's always a character. It's always a string. And it's going to parse it behind the scenes into a number, and it's going to throw an error. So you always want to try to think about how, when you're writing these type of programs, how you're going to validate it with the user. And it's something to keep in mind. And we're not going to really talk about that too much. Okay, let's close this one out now. There are all kinds of, I'm going to create one other class here. And we're just going to call it types of variables. And public static void main, hit tab. So when we're creating variables, we can create variables of type string, my string equals hello. We can create variables of double, which is a decimal point number. My desired rate. You can create, of course, as ints. You can create other longer type of variables, and these this is called a long. And how long I want to live. That's a long variable name. Longs are in the billions, so very large number. What's it complaining about? Integer number too large. There we go. Ints and longs, they have a floating decimal point range. Excuse me, a range between negative and positive, and of course your text is going to talk about that. You can also create numbers that are of type float, and float is a little bit different than a double. They're both decimal, but for a float, when you declare them, you have to declare them using a letter sequence at the end. So if we say rate equals 55.5, we also have to put an F at the end for float. Floats are in the same length range as a long. Doubles are in the same length range as an int. You also have short values. Short number. I think a short number only goes up to 100. Let me Google the types of variable lengths for you. Okay, I'm going to drag this over into this window. This is from the Java docs, and it basically talks about the types of primitive values you have here. So an int is a 32-bit signed number. A short can go up to 32,768, whereas a int can go up to negative 2 to the 31 or 2 to the positive 2 to the 31. Long is a 64-bit number. Your floats, same thing, double. Then you have your booleans and your chars. So I recommend, if you have time, to go ahead and look at the Docs Oracle site. This kind of gives you the these are the standards for these values. Okay, this video has gone very long, so I'm going to kill this video and we're going to do another one in a moment on branching.